we'll discuss about exception handling, that is third part of module 3. So under this topic we'll discuss what do you mean by exception, uh, how to generate exception, once exception is generated, how to handle it, why exception is so important, what are the different methods to handle exception. Now first, so let's see about what do you mean by exception, that is exception handling fundamental. So exception is an abnormal condition that arises in the code sequence at runtime. That indicates that exception is a runtime error that occurs during runtime, not compile time. Or I can say exception is error that generated during runtime. Okay, if a computer language that doesn't support exception handling, then error must be checked and handled manually. Java exception is an object that describes an exceptional condition. That indicates that in Java each exception is represented as an object. That object describes what is that exception is. When an exception is condition arises, when an exception condition arises in a program, then the object representing that exception is thrown. Once that exception is thrown, that must be caught and processed. That indicates that you need to catch that exception and you need to process that exception, otherwise your program will terminate in between. Now how Java exception handling is managed. The Java exception handling is managed by using 5 keywords, that is try, catch, throw, throws and finally. Now what is the need of try? The part of the program or part of the code where there is chance of getting runtime error, that must be placed over try block. The purpose of this try block is to monitor the code. Once that error is generated in the try block, that will be thrown. Once that thrown exception, then how to handle it? Then you need catch block to catch that exception and to process that exception. For that reason we need catch block. Now this is the skeleton of exception handling. So it starts with the try block. The purpose of this try block is to monitor for error in the part of the code. So next it is followed by multiple catch blocks. So each catch block is is a handler for a particular type of exception. So later it ends with finally block, the code which you want to execute immediately after try or catch block. Try catch block, then we require finally block. So now before getting into exception, if there is no proper handler for exception in Java, what happens? Then it will be handled by default handler. What is the default handler does? It just display the type of the error, I mean to say exception, and where it is where that exception is occurred. So in this code you can observe the output of the handler. So it displays a java.lang.arithmetic exception divide by 0. That indicates the type of the exception which occurred. So in that code you can observe int d is equal to 0, int a is equal to 42 by d. Now value of d is 0, for that reason it is divided by 0 condition. So next line, so at ex0.main, ex0.java 4, that 4 indicates line number 4 in the file called ex0.java. So that exception is occurred in main method. So this is the output with respect to default handler. So if there is no proper exception handler. So next program or next example. So here the same program is implemented with the help of one extra subroutine, that's all. So now how default handler will handle it. So first line it displays the type of the exception, that is divided by 0. Next it display exe1 dot subroutine exe1 dot java, for that indicates that line number 4 in exe1.java under subroutine, under the subroutine. Again, that subroutine is called within main. For that reason, it displays the next line exe1.main, that indicates that within the main call is occurred for subroutine, and that line number is exe1.java. Sorry, exe1, that is seventh line of exe1.java. Now, handling exception by using try and catch block. So if there is no proper handler, so your program output will be the output of the default handler and it will terminate. Now we need to guard against that runtime exception. Now we can handle it by using try and catch block. The code where there is chance of getting error, you need to place that within try block. Later you need to write the number of catch clause. So this is one example. The within try block we written d is equal to 0, a is equal to 42 by d, and system.out this will not be printed. So this part of the code is placed over try block. Why? Because there is a chance of getting runtime error. So immediately we return the catch block. What is that? Arithmetic exception, divide by 0. Now when you are running this program, say d value of d is 0, so obviously a is equal to 42 by d is nothing but divide by 0. Once that runtime error is generated, that runtime error will be thrown out of the try block. Immediate to the try block there is a catch block. That catch block will catch that runtime error and it will handle it. So here we are just displaying that. So it is a divide by 0 error. So later it will continue with the program. So for that reason the output with respect to this program is divide by 0 and after the catch statement. The line which is immediate to that a is equal to 42 by d will not be printed. Why? Because there is error in the previous line. So next, it is multiple catch clauses. Why that multiple catch clauses required? So if a particular code generates multiple runtime error, then we need multiple catch clause for each type of the runtime error. So here you can observe, so there are say 3 types of runtime errors. One is divide by 0 and array index out of bound. For that reason we implemented 2 catch blocks. One catch block with arithmetic exception, another catch block with array index out of bound exception. Now when you are running this program, that is java.multicatch, and you are not passing any command line argument, then value of a will be 0. Why? Because int a is equal to args.length, number of argument. When the value of a is 0, we will get divide by 0 condition. For that reason the first catch block will be used. When the value of a is other than 0, then we will get array index out of bound. Why? Because uh, int c, that is array, is equal to 1, that indicates that c of 0 is equal to 1. Next, c of 42 is equal to 99, so that 42 is not at all there, index is not at all there. Now you are trying to access it. For that reason you will get error, array index out of bound exception. Then the second catch block will be used. So this is the output with respect to previous Java multicatch. Only now the command line argument, the number of argument will be 0, and for that reason say divide by 0 condition. So next, if you are passing one argument, that is test arg, now number of argument will be 1, then value of e will be 1. Now you will get array index out of bound. So next is nested try. Nested try statement indicates that one try statement within another try statement. The try statement can be inside a block of another try. If an inner try statement does not have catch handler for a particular exception, the stack is unwound and the next try statements catch handler are inspected for the match. That indicates that if there is a runtime error generated by the inner try statement and there is no matched catch block with respect to that particular runtime error or exception, then the match will be identified with respect to the catch statements of outer try block. If no match, if no catch statement matches, then the Java runtime system will handle the exception. That indicates that just display the type of the error and where that runtime error is occurred. So this is one example. Say here you can observe, say one try is within another try and array index out of bound is catch statement with respect to inner try. That arithmetic exception catch statement which handles arithmetic exception is catch statement with respect to outer try. Now if there is a chance of getting divided by zero condition within the inner try, then there is no matched catch block, then that will be handled by the outer catch block, that is arithmetic exception catch block with respect to arithmetic exception. That runtime error will be handled by that catch block. That catch block is with respect to the outer try. So that is the use of nested try. So this is the output with respect to that. So next it is throw. So it is possible for a program to throw an exception explicitly using throw statement. The purpose of throw is to explicitly user can create runtime error. The general form of throw is shown here, that is throw throwable instance. That indicates that that instance must be of type throwable. Throwable instance must be object of type throwable or subclass of throwable. So that throwable instance must be object of throwable class or subclass of throwable. So here is one example. If the age is less than 18, throw new arithmetic exception not valid. Now you are creating your own exception and description of that exception is not valid. So now throw is used. It will so here in the main program we are calling that validate function and by passing 13. Now the age is less than 13. Obviously it will generate one runtime error, that is new arithmetic exception and description of that exception is not valid. Throws. Throw throw statement creates you can create runtime exception explicitly. Now throws that doesn't mean that it will create multiple runtime error. The use of throws is completely different. If a method is capable of causing an exception that it does not handle, it must specify this behavior so that caller of the method can guard themselves against the exception. That indicates that if a particular method causes runtime error and we are not handling that error in that method, then we need to guard that method such a way that caller of that method can handle it. So in this way you can use the throws. So include a throws clause in the method's declaration. So in the method declaration you need to include the throws clause. A throws clause lists the types of exception that method might throw. So below on syntax is given type method parameter list throws exception list. That indicate that exception list indicates that number of or different type of exception that method can generate, but it will not handle it. The caller of that method must handle it. So here is one example. Void method throws IO exception. That indicates that that method will generate one exception, that is that IO exception, but it is not handling it. The caller of the method must handle it. So the main method is calling that method called method. Now that method is not handling it, but it will generate error. The caller of this method called method, who is that caller of the method? That is nothing main must handle it. So next keyword is finally. So finally creates a block of code that will be executed after a try catch block has completed and before the code following the try catch block. That indicates that if you want to execute a set of code immediately after try and catch block, then you need to place that code in the finally block. If an exception is thrown, the finally block will execute even if no catch statement matches the exception. That indicates that final block will be executed even though there is no matching catch statement with respect to try. Finally, finally clause is also executed just before the method returns. Even though if there is a return statement before returning something, your final block will be executed. So here is one example. So three different way we represented final block. So in the first that is represented in red color. So finally block is created immediately after try. Now that part of the code generates runtime exception. During that time also your finally block will be executed. And in the next black color part or within method called pros b. So before the finally there is a return that indicates that function must return from that. But before returning it will execute final block first, then it will return. So next it is simple example. So immediately after try block it will execute finally block. So this is the use of final block. If you want to execute a set of code immediately after try or catch block, then you can use finally block, even though there is a return statement, even though there is a runtime error. When during that time also your final block will be created executed. So this is the output with respect to that. So creating own exception subclass, that indicates that you can create your own exception subclass. Then that exception must be subclass of class called exception. So now I am creating a class. What is that? Invalid age exception. I am creating my own class called invalid age exception extends exception. That indicates that I am creating a exception. What is that exception? Invalid age exception. But that class must be subclass of class called exception. So inside that I am written the constructor of that constructor initialization part will be taken by super. Yes, that is nothing but it calls a constructor of exception class. We already discussed what is the use of super. So next within test custom exception one. So I'm in the first part I'm okay there. So it throws statement throws is used invalid age exception. That indicates that it will there is a chance of getting invalid age exception. And creating my own exception by using throw new invalid age not valid, else welcome to vote. Now once that exception is generated, it must be caught and processed. So that part is written in main part. So why? Because I'm implementing or I'm creating exception by using the subclass of exception, and throws statement is used. Throws statement is used when the particular method is not handling it, but there is chance of getting runtime error. When the throw statement is used, that must be guarded or that must be caught and processed in the caller of the method. For that reason I'm catching that exception in the main method and handling it. So next and the last part of the topic, it is chained exceptions. What is that? Chained exceptions. The chained exception feature allow you to associate one exception with another exception. That indicates that you can associate one exception with another exception. That is called chained exception. So what is that one and another? This second exception describes the cause of the first exception. That indicates that you can link second exception with the first exception when the second exception describes the cause of the first exception. So here two methods are used, that is throwable get the cause of the exception. That indicates that one exception is occurred because of another exception, that second exception is the cause. And another method is init cause. That indicates that you can initialize the cause. So here class is created, that is chain exe demo. Static void demo proc method is written. Now null point exception e is equal to new null point exception, that is top layer. That is nothing but you're creating your own exception, that is null point exception. Now we are initializing the cause of that e dot init cause arithmetic exception. That indicates that null point exception is occurred because of arithmetic exception. We only initializing it. Now throw e, that indicates that you are throwing that exception or you're creating that exception. What is that exception? Is nothing but null point exception. Null point exception occurred because of arithmetic exception. For that reason we initialized that cause with respect to arithmetic exception. Now in the main method, catch null point exception, system.println caught e. Now which exception is caught? Arithmetic exception. Now system.println original cause e.get cause. That e.get cause returns what? Cause of the null point exception. Which is the cause of the null point exception? The cause of the null point exception is the arithmetic exception. So that is the end of the part 3 of module 3. So in the next part we'll discuss about module 4. Thank you.